Okay, welcome back reinforcement learning. This session I explain the pros and cons of evolutionary algorithms. Okay, advantages and disadvantages of evolutionary algorithms. Evolutionary algorithms are optimization techniques inspired by the biological evolution and natural science evolution. We are taking the natural science mechanisms in reinforcement learning optimization techniques to optimize the results like the selection and mutation and crossover approaches in biological evolutionary approaches. We are using the optimization techniques to optimize the results. They are often used for problems requiring the exploration or when gradient based approaches are failed or unsuitable to that application. We are using this type of evolutionary algorithms, and this section is we see the what are the advantages, what are the drawbacks of the evolutionary algorithms compared with the traditional gradient descent optimization methods. Okay, the first one is the pros of evolutionary algorithms. The first one is enhanced exploration capabilities. It has the more exploration capabilities compared with the gradient descent optimization methods. The evolutionary algorithms tend to explore the solution space more thoroughly than gradient based approaches. They generate a diverse population of solutions. It has a diverse population, it has multiple solutions, which allows for the broader search for potential solution for the problem. This is particularly beneficial to solve the complex problems for the local optima may turn the gradient based methods. Okay, it is focused, it is give the global optima focused methods. So it is a more exploration capabilities compared with the gradient based methods in evolutionary algorithms. The second advantage is gradient free. It is not required the gradient operations. Evolutionary algorithms don't require the gradient information, making them suitable for the problems where the objective function is not differentiable or it noisy. Where the gradient is not required, the type of applications we are directly use the evolutionary algorithms. We need not require the gradient, and we not differential calculations. This characteristic allows them to apply it in a wider range of scenarios compared with the gradient based methods. So it is not required gradient data for the problem solution process. And robustness. Due to the exploration nature, evolutionary algorithms is likely to converge prematurely to local optima. They maintain a diverse population of the solution, which increase the chance of global optimum. So they are focused or global optima compared with gradient descent is focused on local optima. This is the robustness to the local optima. Okay, these are the advantage of the evolution. One more advantage is evolutionary algorithms the more suitable for any type of problems. The evolutionary algorithms can be easily adapted to different types of problems, and they can be incorporated various types of representations and various types of operators, making them versatile tools for optimization. It is easily we can use in any type of operations, any type of environments. So it is a flexibility. These are the advantages of the evolutionary algorithms. The first one is enhance the exploration capabilities. Have the more exploration capabilities compared with the gradient based optimization methods, and it is a gradient free type of optimization method, and it is robust to local optimum, and it is flexible to any type of environments. And now come to the drawbacks of the evolutionary algorithms. The sample inefficiency. Okay, it is the evolutionary algorithms are sample based approaches. It requires the number of samples. Evolutionary algorithms often more sample intensive than gradient based methods. They require the large number of evolutions. So they require the large number of samples to determine the fitness of the individuals in the population, which can be computationally expensive and time consuming. It requires the number of samples to get the best individual scores. So it requires the more computational expensive and time consuming process. That is the drawback of the evolutionary algorithm. It is a sample inefficiency. The next one is computational cost. The computational cost, it requires the number of samples, number of operations, it requires the number of computational data is required. So the computational cost is more expensive. The need to evaluate the many individual operations in each generation can lead to high computational cost, especially in the environment which data collection is expensive, and such the robotics or autonomous vehicle cases, the data collection is more expensive in robotic operations and autonomous vehicle operations. This type of operations, the computational cost is more expensive. So this is the one more drawback. The next one is the parameter sensitivity. The performance of evolutionary algorithms are more sensitive to choose the parameters. So the population size, mutation rate and selection methods. Okay, we are the hyperparameters. Okay, population size, mutation rate and selection methods. Okay, these are the hyperparameters we are in the we are seeing genetic algorithm. So we select the poor parameters, they lead to the worst performance. So poor parameter choice can lead to the suboptimal performance. So the parameter sensitivity it is also parameter sensitive type of approaches. The next one is convergence speed. So compared to gradient based approaches, it is the slowly convergence. Evolutionary algorithms are good at exploration, but they make convergence more slowly than gradient based methods, particularly in well defined optimization problems where gradients are available. When the gradients are available case, they are convergence fast compared with the evolutionary algorithms, and it requires more simulations in practicality for real world application without simulators. So in robotic cases and some cases, for domains like the robotics, the cost of physical experiments can be prohibited. In that case, we are dependent completely on simulations. So without simulators, the feasibility of applying the evolutionary algorithms decreases significantly. So in this case, it is more rely on simulation, some type of domains. So these are the drawbacks of the evolutionary algorithms compared to gradient based optimization methods. The first one is the sample inefficiency. It requires the number of samples. So it leads the cost expensive, computationally and time consuming. And second one is the computational cost. It requires the more computations compared to gradient methods. And the parameter sensitivity. We have seen the poor parameters, it is the worst performance. And convergence speed compared to gradient based methods where the gradient is available cases, it is more slowly convergence, and it is more rely on simulators in some domains. So the evolutionary algorithms offer the powerful alternative to traditional optimization methods, particularly in scenarios requiring the extensive exploration and flexibility. But however, the sample inefficiency and computational cost can be significantly drawbacks, especially in data intensive applications. So understand these pros and cons of evolutionary algorithms is crucial for selecting the appropriate optimization strategy for given our application or given our problem. So the selection of the gradient based optimization or evolution optimization depend on our application, which one is suitable for our application. So evolutionary algorithms have some drawbacks and some advantages. We decide which optimization is suitable for our application is necessary to choose the optimization methods. So this session explained what are the pros and cons of the evolutionary algorithms. Thank you.